and salam sejahtera to Madam Nur Salihah. My name is Lim Jahui and my number metric is A20A1424. Today, I'm going to present the assignment about the business activities. The topic of our assignment is the total population affects the total case road accidents. First of all, I'm going to present the data description. The data description is about the road accident and population by state in Malaysia from year 2016 to year 2018. The data that is by secondary data, and the variables is states, years, status of victims, and populations. The data is quantitative data as the value of data in form of count or numbers. And for category, which are causalties, death, total cases, and population. The data then is divided into each stage. Next, I'm going to present about the graphical representation, which is frequency distribution for group data. First step, we need to determine the number of classes. There are one formula to determine the number of classes, which is 2k is bigger than 42. 42 is our n. Okay, so from this formula, we know that 2 times 6 equals to 64, which is bigger than 42. So our classes is 6. Next step, we need to calculate the class width for each data. The formula for class width is maximum data entry minus minimum data entries, and then the answer divided by the number of classes. For example, total consultees, the maximum data entry is 162032. Then the minimum data entry is 1863. Then we minus the both number, then we divide it by 6, and we get the answer 26695. Next is about how to present our data into graph. We use histogram graph and orgif graph. Okay, first, we need to calculate the cumulative frequency, lower boundary, upper boundary, and midpoint of the data. From the graph, we know that the highest frequency of the total causalties caused by road accidents from year 2016 to year 2018 is 27, and the midpoint of the class is 15210. While from the orgif graph, we know that the x-axis is using the upper boundary of each classes, and the y-axis is using the cumulative frequency. Next is the total death caused by road accident from year 2016 to year 2018. Same as before, from the graph, we know that the higher frequency of the data. The higher frequency of the total death caused by road accidents from year 2016 to year 2018 is 16, and the midpoint of this class is 331.5. And from the orgif graph, the cumulative frequency for the first class should be 0. The cumulative frequency for the last class should be equal to the sample size, which is 42. And the next data is about the total road accident from year 2016 to year 2018. From the histogram graph, we know that the highest frequency of the total road accident from year 2016 to year 2018 is 27, and the midpoint of this class is 15354. And the last graph is about the total population for each state from year 2016 to year 2018. From the histogram graph, we know that the highest frequency of the total population for each state from year 2016 to year 2018 is 15, and the midpoint for the class is 1803700.5. This table is about the total population by state and years. We divided the total population into 3 years, which are 2016, 2017, and 2018, and we also categorize it in different stages. Okay, then from the table, we now proceed to the histogram graph. From the histogram graph of the total populations by state of year 2016, we know that Selangor has the highest population between other states, which is 6291500, and the population of Perlis is the lowest, which only 251000. And next, from the histogram graph of the total population by states for year 2017, Selangor also has the highest population between other states, same as the year before, and the total population of Selangor increased into 6380700, and the population of Perlis is still the lowest, which only 252000. And next, for year 2018, the population for Selangor is increased to 6475000. The population of Selangor every year keep increasing, same as the population of Perlis is also the lowest one, which only 252000, and the population of Perlis increased in small amount. It's about the total road accidents by state and years. Same as the population, we also categorize the total road accident into years and states. Then we proceed to the histogram graph. From the graph, we know that the highest total road accident is happened in Selangor for the 3 years. The lowest total road accidents is happened in Perlis, same as 3 years. The factor that caused Selangor record the highest cases of road accident may be the population of the Selangor. It's because Selangor has the highest population. When the population in the state is high, the government and work opportunity also may be high. So the transportation at Selangor will also increase. At the same time, the road accident that happen will also increase. Next is about numerical restrictive measures. We need to find out the mean, median, and mode of data. First, the mean. We use the formula of mean to find out the solution. So the solution for mean of total casualties caused by road accident is 36184.64 and median is 22625.28. And next is mode. We also use the same formula of the mode. Then we find out the solution is 16878.44. Next is about the first quartile and the third quartile of the total casualties caused by road accident. The first quartile, we use the formula of the first quartile and we find out the solution of first quartile is 12243.89 and the solution for third quartile is 48578.75. Next, we can find out the answer for interquartile range. We need to negative the third quartile to the first quartile. So we get the answer 36334.86. And the next is variance. Same, we use the formula of variance and we find out the solution for variance is about 1374344.05. And next is standard deviation. The formula of standard deviation is square root the answer of variance. So the answer is about 37072.15. And then lastly, we need to find out the shape of distributions. After finding out the mean, median, and the mode, we have a solution stated that mean is bigger than median and is bigger than mode. Therefore, the graph is true to the right as shown as the below. Same for the total death caused by road accident. We also need to find out the mean using the formula, and the solution should be 468.64. And median, we should also use the formula of median to find out the solution, and the answer should be 387.75. And next is mode. By using the formula of mode, we calculate out that the solution of mode is 337.5. Next is quartile. First quartile, the answer is 269.625. And the third quartile, the answer should be 2461.5. And to calculate in the quartile range, it is the third quartile minus the first quartile, and the answer is 2191.875. And for variance, same also as before, we need to use the formula of variance, and we calculate out the answer is about 83464.81. Same as standard deviation, we're using the formula of standard deviation, which is standard deviation equal to square root of the variance, and the answer is about 288.90. And the shape of distribution of the total death caused by road accident, we can conclude that mean is bigger than median and is bigger than mode. Therefore, it is grouped to the right, as shown as the below. Next is about the total road accident. Same as before, we need to calculate out and do the table before we calculate the mean, mode, and median, and so on. For mean, we also use the same formula, and we get the answer 364.57.5. And for median, we also use the formula given, and we find out the solution is 22814.83. And for mode, the answer should be 17032.69. Next, we are going to calculate the quartile. For the first quartile, we use the formula to calculate, and we get the answer 12369.67. Same as quartile 3, we calculate out the answer is 48927.75. And next, we are going to calculate the interquartile range, which is third quartile minus first quartile, and we get the solution 36558.08. Next is variance. By using the formula, we can calculate out that the variance is about 13912.82770.5. And for standard deviation, the formula is square root the variance, and the answer is about 37299.90. And next is the shape of distribution. From the calculation, we know that mean is bigger than median and is bigger than mode. Therefore, it is screwed to the right. The table below shows the solution. And the last one is the total population. Same as before, we produce a graph before we do the calculation. For the mean, we use the formula of mean, and we get the answer 2473858.071. And for median, we also use the formula to calculate our answer. And the answer for median is 2118200.7. In the mode, we also use the formula, and we get the answer is 1703267.1. Next is the first quartile and third quartile. First quartile, the answer is 1392066.9, and the third quartile is 3535890.5. And next, we are going to calculate out the interquartile range, which is third quartile minus third quartile is equal to 2143823.6. And next is variance. By using the formula given, we calculate out that the variance is about 2142750299000. And for standard deviation, is square root the answer of the variance, and the answer is about 1463813.615. And lastly, we're going to do the shape of distribution, and by the calculation, we know that mean is bigger than median and is bigger than mode. So the graph is screwed to the right, shown as below.
My name is Ang Jia Singh. My number matrix is A20A1267. Now I'm going to continue our presentations, statistical analysis using software. This table is showing the total casualties caused by road accidents, and this table is showing the two calculations, which is the formula and software, and we can see a difference in these calculations. This table is showing the total death caused by road accidents, total case caused by road accidents, and the total populations. Next is the hypothesis testing. Here has 5 main steps in this testing. The step 1 is test null hypothesis and alternate hypothesis. The step 2 is test the level of significance, which is 0.05 level significance. The step 3 is compute test statistic. We have 2 tests in this test statistics. First is the t-test. This here is the table of calculations of t-test. And the next is ANOVA. And these are the calculations of ANOVA. The step 4 is decision rule. If we want to reject the null hypothesis in t-test, the test statistics must less than or more than critical value. And in ANOVA, if we want to reject null hypothesis, the F must more than or bigger than F alpha, V1 and V2. And the last step is decisions. In t-test, we have rejected the null hypothesis since 6.154544556, which is the test statistics, is more than 2.019540997, which is critical value. And in ANOVA, we also reject the null hypothesis since F is bigger than F 0.05. This slide showing 2 tables. The first table is correlations analysis. This table is showing the relationships between causality and depth. And the next table is showing the confidence interval. And we can see the difference in the mean, standard average, median, mode, standard deviations, and more for the causality, depth, total cases, and populations. This slide is showing the theoretical modeling. Based on the calculation of this paper, which has concluded a linear regression with each y equal to 0.021 x1 and minus 9031.042 x2. x1 is the populations in 3 years, and x2 is the total case road accidents in 3 years. And we have made a conclusion that for the 3 additions years for populations, the total case road accidents has increased by 0.021 cases. And the last slide is our conclusions. All the data that we used in this assignment was secondary data. We also used the numerical, descriptive, and calculate the mean, mode, median, quarter, variance, and standard deviations. And we also conclude the shift of distributions of each data. And we also had analysis data using a table and suitable graph, which are histogram and OGIF. And we also calculate some of the data by software. We have learned the calculations of the software and found the difference between the calculations by formula and software. And we also calculate ANOVA analysis, multiple regressions, confidence interval, correlations, and regression statistics. Here's all our presentation. Thanks for spending your time to watching our presentations. Thank you.